guess you're probably wondering why, at this time of year, I'm sitting in front of a fireplace. Well, while the rest of you south of Colorado are experiencing a true spring with budding flowers and sunshine, we're getting the sunshine, but we're also getting snowstorms. And right now we have a lot of snow on everything. So this fire is feeling pretty good. We go between 30 to 57. It's crazy in the spring here, but you get used to it. In this video, Paul is going to be showing us the instrument and mechanical side of Sea Oasis. And I have to admit, mechanics are just not my strong point. I'm going to be learning about the mechanics of this boat forever, I think. I found that as I watched and worked on this video, I learned a few things and got some clarification on some questions I had as Paul explained all the details of the boat. It's going to help me. I think I'm going to review it several times in the next few months. Hi, I'm Sandy.
And I'm Paul, and we're aboard Sea Oasis. We're now living part-time in Washington, in the San Juan Islands. We always enjoyed outdoor activities and exploring, so now we're spending time exploring this area as well as Canada and eventually Alaska.
And we want to share our experience and adventures with you and people like you who enjoy the same kinds of things. So welcome aboard.
Hi, we're just showing you some of the features on the helm or the controls for the boat, which are on this lower helm. They're also repeated upstairs in the upper flybridge for the most part as well. To start with, here's the VHF radio used typically on channel 16 for cruising. It's to communicate with other boats if you needed to make an emergency call to the Coast Guard. In this case, it's on 66 Alpha, which just happens to be a standard channel for marinas. Next to it is the Garmin GPS. It's a map plotter. It also has a lot of other information. If we were underway, it would tell you how fast we were actually moving across the water. Actually, I should say across the ground, not necessarily across the water because the water has current, but it's GPS speed. It'll also give GPS heading, which is really, right now it's not reflecting it, but when everything's turned on, the compass would be showing essentially the same heading that's here on the screen. It gives GPS current position. Like if you need to tell somebody right away your latitude, longitude coordinates for, I think of that mainly for the Coast Guard for rescue issues. And then in this case it gives our depth. So it's a depth finder as well. And you can, we're in a marina now, and this will show, actually it shows AIS or Automatic Information System information on boats that also have AIS. In other words, here's one called the Explorer. They're color coded. If they're actually underway, it would give you information about their speed, the name of the boat, whether it's under sail or under power at anchor. So there's a fair amount of information that's available. It's kind of like a transponder system on an airplane. This will zoom out. Right now it's at 80 feet. We can zoom it in. Down there's 30 feet. You can see our boat in the slip down to 20 feet. The black and white indications are tracks. So they're tracks of where we've been, where the boat's been. At some point you can erase the tracks, but just information. I can zoom out. In this case, we had a course plotted automatically by the Garmin to this point here at basically the head of the marina, and the magenta line would go back essentially to show our route coming in into this area. There's a fair amount of capability with a GPS. You can see the numbers on the chart indicate the depth of the water. It actually gets into like a Google map type look when you zoom out, showing the highways, but more importantly is the water, the depth. And if you give the information to the system of the depth or the keel depth of the boat, or the draft, in our case about 4 feet, and with this GPS ask it to guide you to a point, it will avoid any water that would be such that you'd basically hit bottom. You can tell the keel depth and how much water you're looking for, and the GPS knows basically where to steer you. There's a lot of information in the menu. This would be other vessels, talking more about the AIS system. If I go into the home page, it gets into charts, setup of the sonar or the depth finder, just configuration like settings. Man overboard is where you could just touch that if something or someone fell over, and it would make a mark on the chart to show exactly where that occurred. This has the ability to overlay radar on top of the chart, which is shown here. So you can set up the radar so it has an overlay on top of the moving map. Anyway, that's some of the basics of the Garmin unit. Over here are just essentially like warning lights. There's sump pumps that are running. If one of them is running, it would light that up. If the bilge level's high, this shows a fire sensor, which quite honestly, actually it is hooked up in the ceiling of the engine room, just sensing high temperature. Then it would tell you if you had left, or if the engine room or Lazarette lights are on. The last two are just preheats for where if we're going to start the engine. In this case, you can see the lights come on, and when as long as they're on, the glow plugs are heating in the engine just to get it basically ready to start. When the light goes out, the glow plugs have gone up to their designated heat level. Going back to this is the Autopilot. It's basically turned on now, and once it's activated, we can turn the Autopilot on and essentially use this knob to steer headings. It comes on in your present heading, and then rather than the wheel, you can just turn this knob to select a new compass heading, essentially a track, and it automatically adjusts the rudders to maintain that heading or that track. Takes away a lot of the work of, and actually does a better job. It's quicker than doing it manually with a wheel. So for longer distance cruising, it's a great thing to have, just to allow you not to leave the helm, but just to relax and watch out the window and let the system do the work of steering. We got 3 windshield wipers down here with intermittent settings. Then these engines just voltage off of the engine alternators as they charge the batteries. Temperature for the coolant fluid, engine RPM. This is oil pressure, and this one is transmission pressure. Obviously the keys to start, and as long as the Autopilot is turned on, then we have a rudder indicator, and this again is duplicated upstairs, but as the wheel's turned, you can get an idea of where the rudder is. It seems like, well, that should be pretty obvious from where the boat's going, but if you're at slow speed and just getting started, it's good to know that the rudder's centered. The other thing we've got here on this lower panel is just a cluster of switches for instrument lights, basically lights, the horn, starter assist, which just hooks up the house batteries to the start battery if it's gone dead. And then we can actually control the anchor winch from here, which typically we don't do. We do from up on the bowsprit where foot controls are, a defroster fan, and then these are actually switches to engage the bilge pump. The switches here for the trim tabs back underneath the swim step, or back near the swim step for trimming the bow up or down. These indicators show where the trim tab position is in percentage of degrees down, and you can see as they push the switches, it gives indications both in light and in a digital format. Typically they're left all the way up at anchor or in the marina, just to keep the hydraulic tubes contained into the cylinder. These are electronic engine controls. Right now the switch is on. That allows for use of the this basically head here, which again is duplicated upstairs. It has a station select, which can be selected here or on the upper fly bridge to determine which set of throttles operate, either up there or down here. These are a combination of throttle and transmission, as opposed to a lot of boats that have 4 sets of levers, 2 for the throttles, 2 for the transmission. You can see on the side it has forward, neutral, and reverse, and as when the engine's running, as the lever is moved, either as you move further forward you get more throttle, then it clicks into neutral, and you come back, you get more throttle in reverse. Station lock just is a way to lock out this station so nobody can take control without if you don't want someone to be able to take control upstairs. There's a throttle override, which when that is selected, it allows the throttles to be operated to run the engine up in RPM but not engage the transmission. Almost look at this as a transmission override, so that just the engines work, not the transmissions. Then has a synchronization mode, which is intended to just sync up the engine so you don't get sonic, basically out of sync sound with the engine just running at different RPMs. This right here is the bow thruster, which you can hear. It just operates a electric hydraulic motor that operates a set of blades up in the bow to basically push the bow left or right. Some boats have them on the stern as well. This one only has a bow thrust, not a stern thruster. In this cabinet here, these are some backup engine controls that would operate if the main throttle quadrant stopped. You can activate these switches to tell whether it's in the main system or the backup system, and then these switches would be obviously port ahead, stern, port astern, starboard ahead, starboard astern. So they're almost duplications of the throttle quadrant as a backup system.
More of a manual system? Is that what you mean?
Well, it's still electronic. It's just a backup system for these handles.
Okay.
All right, on the electrical panel, which is obviously on the level between the main salon and the pilot house. To start with, over here, obviously there's a fire extinguisher, but this is called a tank tender over here. So this is how we read the tank readings for fuel, fresh water, gray water, and black water. The way it works is basically, if it's in the read position, you can hold the button in. This is for the port fuel, and you pump this slowly, and right now it's reading about 17 inches of diesel fuel. So the outer scale is diesel, the inner scale is water, showing about 17 inches of diesel. And according to this reading scale, 34 inches is full, 250 gallons. So what's it telling you? We're at about 50% fuel in that tank. If I go to the freshwater tank, number 3, and push it, I'm reading here about, I don't know what it is, about 16 inches of water. So full on number 3 is 24 inches. So whatever, we're 2/3 full on the water. That's two. It reads actually from 2 different tanks because there's 2 100-gallon tanks. Just like for the fuel, there's individual gauges, but there are 2 250-gallon tanks for a total of 500 gallons of fuel, 200 gallons of water, 85 in gray, and 80 gallons of black water. Anyway, that's how it's read. Up here is the electrolysis indication. It just shows based on zincs and grounding and all. It's, as it says here, it's a corrosion system monitor. So this has a needle that shows that we're in a good place on corrosion protection. This whole panel here is the electrical panel, which is divided into DC power, which is battery power. Then here is the inverter, which converts battery power into AC power, just like you get out of your house outlets. And then you get into a meter that can tell you the condition of the batteries, the house batteries, hour meters for the engines, and then a switch to select either shore power or the generator. These controls are all for the generator, an hour meter. There's temperature indications, voltage or cycles per second to show that it's producing the right kind of current, and obviously the preheat and the start switch. On this side is a 120 volt AC distribution, which is either as we are now plugged into shore power, so we get regular 120 volt power into the boat. That power basically keeps the batteries charged, and it supplies all these things that are on the AC power distribution. Below it is the inverter distribution. The inverter will take battery power and convert it to AC power, just like the power coming in basically from the marina. These are all broken down into different components that are powered either DC, 120 volt AC, or through the inverter. If we wanted all of this powered and we were not hooked into shore power, then we would start the generator. The generator can provide AC power just like shore power, and it can also charge the batteries. So the boat is self-contained as far as power is concerned, so that we have all these things available as long as the generator and batteries are available, even when we're away from a marina. Okay, we're down in the Lazarette area, which is down below the cockpit. You can kind of see the hatch open there. So we come in here. First off, we got this washing machine we bought last summer. There was a space over here for a washer, not so much a dryer, but a washer. But this space was taken by a water maker that converts salt water into fresh water. So it's reverse osmosis, which you can look up and see how that works, but he basically uses membranes and draws the water through membranes with a high pressure. It can convert, if it was running 24 hours a day, up to 600 gallons a day of raw water or seawater into fresh water. Naturally, we don't run it that long, but it does a good job of converting fairly quickly. That's where There's also provision for a washing machine, but since we had the hose bibs or the connections, what we did is ran lines and put this small washing machine in here that we've been using all last summer, and it does a good job. It takes, I think, 8. In the summer, it's not a problem drying. Just put the stuff, clothes up in the fly bridge in the sunshine. They dry in a couple of hours. Back behind the washing machine, that component here is actually a furnace. It's a diesel furnace, and it's called hydronic heat, so it runs like baseboard hot water. It heats up a water system that circulates hot water through the boat into different zones, and then uses fans over heat radiators to force warm air out into the 2 staterooms or the main salon area. Down here are the 2 freshwater tanks that we can fill up externally from a regular hose, or are plumbed into the water maker for the conversion of salt water into fresh water. But there's 200 gallons. Down here is the Lazarette sump pump. It has an automatic float switch, so as the float comes up, if water were collecting here, then it turns the pump on and pumps this area out. In addition to that, there's another small sump pump down here. This is more a bilge pump. The ones under the floor are smaller sump pumps that just catch water in the very lowest part of the hull. Okay, so we're in the engine room now. We're just looking forward from that Lazarette area where the water tanks and the washing machine were. These are the 2 Caterpillar diesel engines. They're called 3126. They're 420 horsepower. They're turbocharged and have regular transmissions on the back here on both sides. The transmission's mounted to the rear of the engine, and then if you look down, so here's the engine, this is the transmission. You can see the shaft coming out of the transmission, and that's what goes back to turn the propellers. So when the engine's running, it's in gear, the shaft's turning. These tubes are just raw water that keep the shaft lubricated when it's turning. It's more like it's basically water lubrication, and they run a continuous loop to both shafts. So if one engine was not operating, the prop's still going to spin just because of the movement through the water. So that water system would keep the shaft lubricated over here. If this was the one that was shut down, the shaft would still be lubricated there. Anyway, these large tubes are the exhaust system coming out of the engine. If you look over here, this is the hot water tank. We've got several things just stored down here, but this 20-gallon hot water tank. Right up above it is a pressurized water system. It has a tank to provide head pressure, then the main water pump, and that feeds back into the whole house water system, including a whole house filter system right there. Okay, above that, the gold colored boxes are just components for the electronic engine controls. So this is the main start battery for both engines. It's big, heavy duty, deep cycle battery. Then contained in these 3 boxes are basically 6-volt like golf cart batteries. So they comprise the whole house battery system, that if we don't have a generator and we don't use shore power, these batteries store a lot of energy, and they can be used for DC power, and through the inverter they can be converted to be used for AC power as well. Up towards the front of the engine room, the silver tanks. These are fuel tanks, one on each side. Remember, they're 250 gallons per side, and they're located about midship. Fuel filters, so the fuel comes out of the tank, runs through filters, and then it's directed to the engine. There's both these, they're water separators for fuel filters, and then there's additional fuel filters on the engine itself. The engines are cooled, both the main engines for the boat and the generator are water cooled. So up in the front there are water strainers where water comes in, raw water from the ocean, runs through a strainer to keep out any debris, and then it's piped or plumbed into the engine or the generator and used as a heat exchanger system to keep the engines cool, as opposed to a radiator and a fan setup like on a car. This is it's an 8,000 watt diesel generator. It's in a sound shield. So basically this is the generator that we can use when we're out for AC power and for charging the battery. So typically we use the AC power from this to get the house batteries charged, which means we run this for 2 or 3 hours a day. That usually completely charges the batteries, and the batteries last easily overnight with a few things that are a draw on them, the refrigerator and a few lights. But this generator is contained in a sound shield just to keep it quiet. There's controls for starting it down here, although we had them up on the electrical panel too. And then up above that is it says power conversion center. It's actually the inverter system that converts battery power into AC power. It also does a lot of other things as far as monitoring generator output, converting power, and all those sorts of things. Pretty extensive control box there, and a big part of the electrical system on the boat. These controls up here are just manual override switches or controls for the throttles for the engines. So if someone needed to, they could actually operate the throttles down here. Maybe if they're working on the engines, need to manually override. These are true manual override throttles compared to the electronic controls that are up on the lower helm and the upper helm. And that's basically it. You can see the whole engine room is soundproofed. That's why it's fairly quiet up in the salon area even when we're underway. And then we've got basically flooring here, just kind of no skid type walkway. Under the engines are what's called diapers. It may be hard to see, but they're absorbent pads, white. So if anything was dripping or leaking, it becomes very obvious pretty quickly if there's a leak of oil or antifreeze or anything else. And that's about it. So this is access in the Lazarette area and down into the Lazarette, the engine room, and actually there's access behind the Lazarette into the swim step because it's an integrated swim step. All the rudder controls and hydraulics are back in there.
Hi, if you like what you've seen, just give us a thumbs up and subscribe. Thank you.